All right, so today we are going to talk about something that kind of goes with something we did earlier in this unit. We're going to be solving absolute value equations and inequalities. And this time, instead of solving them algebraically, we're going to solve them by graphing. So I want to show you it's kind of a trick. It's kind of a hack. Just a way to better understand absolute value. So the way we do this is kind of just a different approach to solving an absolute value equation. So the first thing we're going to do, instead of solving it algebraically, we are just going to rewrite our function. Instead of isolating the absolute value like we did before, we're going to make it equal to 0. So one side we need to make 0. We need to get everything off of one side to where it's just 0 on one side and everything else is over to the other side. Then we're going to graph the absolute value function. And then we're going to find the x-intercepts if possible. Okay, so if they exist, we're going to find the x-intercepts. So the way this works is that we're going to have three possible outcomes. We're either going to have one solution where the vertex of the absolute value graph is on the x-axis. We're going to have two solutions where the vertex is either above or below the x-axis and then opens either up or down to where there's two lines crossing the x-axis. Or we will have no solution where, like if in the picture here, the vertex is above the x-axis and it opens upward. Or it could be, the vertex could be below the x-axis and it opens downward. Alright, so just a quick refresher from the last unit on graphing absolute value functions. Reminder of the different transformations. So we have our h and our k and our a. Just like always, remember h, if it's minus h, that moves to the right, horizontal shift right, h spaces, and if it's plus h, it shifts left, h spaces, whatever h is. Vertical transformations, if it's plus k, it shifts up, k spaces, and if it's minus k, it shifts down, k spaces. Reflections, just like always, if it's positive a, that's going to be no reflection. If it's minus a, then we're going to reflect across x-axis. And if the a is less than 0, sorry, that should be the should be greater than 0, and it should be the absolute value of a is greater than 0, then that is going to stretch vertically. And if a is between 0 and 1, I should say the absolute value of a is between 0 and 1, we are going to compress vertically. Alright, so what we're going to do, we're going to follow the steps, the process here. The first step is to make one side equal 0. So instead of isolating the absolute value, moving it over off the left side, we're going to move things off the right side. So we want the right to be a 0. So minus 5 off of both sides. Absolute value of 2x plus 6 then equals 0. And this 5 and negative 5 cancel out as well as that one. So we're just left with absolute value equals 0. Now what we're going to do is we're going to graph that by making a table xy. I know that my vertex is, let's see, it's going to be whatever makes this inside the absolute value, the x value, it's going to be whatever makes this be 0. So let's see, 2 times negative 3 plus 6 would be 0. So negative 3 is going to be my x value of my vertex. So I'm going to pick some numbers to the left of negative 3. And since it's multiplied by 2, I'm just going to, that actually probably won't matter. So I'm going to pick two numbers to the left of that, negative 4, negative 5, then negative 2, negative 1. So we'll just run those 5 numbers through the function. 2x, the absolute value of 2x plus 6 equals 0. So 2x plus 6, absolute value of that. So if x was, we'll start with the vertex, negative 3. So 2 times negative 3 is negative 6. Negative 6 plus 6 is 0. Absolute value of 0 is 0. So I have a point at negative 3 comma 0. Then negative 4, 2 times negative 4 is negative 8. Negative 8 plus 6 is negative 2. And the absolute value of negative 2 is 2. So that'll go there. And then negative 5, 2 times negative 5 is negative 10. Negative 10 plus 6 is negative 10 plus 6 is 4. The absolute value of 4, and negative 4 is 4. Alright, so like that. Then we'll run negative 2. 2 times negative 2 is negative 4. Negative 4 plus 6 is 2. The absolute value of 2 is 2. And then negative 1. 2 times negative 1 is negative 2. Negative 2 plus 6 is 4. Absolute value of 4 is 4. So there we go. This would continue on forever this direction. And this will continue on forever this direction. And our x-intercept, there's just one, and it's going to be at negative 3, 0. So the solution to this equation, 5 plus the absolute value of 2x plus 6 equals 5, there's only one solution to that equation, and it is negative 3. So it's actually pretty neat how that works. If you wanted to solve that algebraically, going back a lesson just to show you how this would have worked. 5 plus the absolute value of 2x plus 6 equals 5. So going back to what we did earlier in the unit, we would isolate the absolute value. Then we would split into two cases. 2x plus 6 equals, well, we wouldn't have to split into two cases because there is no positive or negative 0. It's just 0. Subtract 6. So 2x equals negative 6. Divide by 2. And x equals negative 3. So that's how we did it. This way is how we did it back, at the beginning of the unit. But just want to show you there's another way to solve this by graphing. And that first example would have been easier to just go ahead and solve it algebraically, but that's not always the case. Show you this one. So solving this by graphing, we're going to subtract 13 off of both sides. So we have absolute value of x plus 1. 9 minus 13 is negative 4. So we've made it equal 0. So now we're going to graph that absolute value, x plus 1 minus 4. So the vertex of that, we can go ahead and xy. Vertex of that, the x value is going to be negative 1. Y value is negative 4. So pick two numbers to the left, negative 2, negative 3. Two numbers to the right, 0, 1. And run those through the function. Negative 3 plus 1 is negative 2. The absolute value of negative 2 is 2. And 2 minus 4 is negative 2. Negative 2 plus 1 is negative 1. Negative 1 minus 4, or the absolute value of negative 1 is 1. 1 minus 4 is negative 3. 0 plus 1 is 1. 1 minus 4 is negative 3. 1 plus 1 is 2. 2 minus 4 is negative 2. Well, we're actually going to have to plot this out a little further than just 5 points. So let's go Looks like they're going up by 1, so what if we ran 3 through the function? 3 plus 1 is 4, 4 minus 4 is 0. So 3, 0, and then if I did like negative 5 plus 1 is negative 4, absolute value of negative 4 is 4, 4 minus 4 is 0. So we've got points at negative 5, 1, 2, 3, 4, 5, 0, negative 3, negative 2, negative 2, negative 3, negative 1, negative 4, 0, negative 3, 1, negative 2, and 3, 0. So it looks like that. And we have those two solutions. So we have negative 5, comma 0, and we have 3, comma 0. So we can actually find the answer to that equation by graphing it. And if we would have ran this through algebraically, like we did back at the beginning of the semester, show you why maybe graphing this is easier. Maybe it wasn't the beginning of the semester, but the beginning of this unit. We would have subtracted 9 off of both sides. Absolute value of x plus 1 equals 4. Split into two cases. X plus 1 equals 4, or x plus 1 equals negative 4. Subtract 1, we get x equals 3. Subtract 1, we get x equals negative 5, which happens to be where we get the x-intercepts. All right. Now, this works really well for solving absolute value inequalities. All right, so the way we solve absolute value inequalities by graphing, first we're going to rewrite our inequality so one side is 0, just like we've been doing. Then we're going to graph the absolute value inequality, or graph the absolute value on the other side, and find the x-intercepts, if they exist, and determine if your solution should be the values above or below. And they're above if it is greater or equal to. It's below if it's less than or equal to. And if it is above, so if it's a greater than or equal to, it is all the areas above the x-axis. If it's below, it's all the areas below the x-axis. All right, so let's take a look at this. 3x minus 9, absolute value of 3x minus 9 minus 6. Okay, so we will make a xy chart. We need the, first of all, determine what number for x would make 3x minus 9 be 0. So that would be that'd be positive 3. So 3 is going to go as our vertex. Pick two numbers to the left of 3, 2 and 1. Two numbers to the right of 3, 4 and 5. And let's see what happens. All right, so 3 times 1 is 3. 3 minus 9 is negative 6. The absolute value of negative 6 is 6. And 6 minus 6 is 0. Then we got 2. 3 times 2 is 6. 6 minus 9 is negative 3. The absolute value of negative 3 is 3. 3 minus 6 is negative 3. Then we have 3. 3 times 3 is 9. 9 minus 9 is 0. The absolute value of 0 is 0. And 0 minus 6 is negative 6. Then we have 4. 3 times 4 is 12. 12 minus 9 is 3. The absolute value of 3 is 3. And 3 minus 6 is negative 3. And then we have 5. 3 times 5 is 15. 15 minus 9 is 6. The absolute value of 6 is 6. 6 minus 6 is 0. So let's plot those points. 1, 0, 2, negative 3, 3, negative 6, 4, negative 3, 5, 0, And so our graph is going to look like this. And then we can just keep it going up like that. So our graph looks like that. Now it's less than, so we're going to be looking for the areas of the graph that are below the x-axis and or equal to, and that is this area right here between those x-intercepts. So our interval is going to be from 1 all the way to 5. And if we were to have solved that algebraically the way we did back in the beginning of Unit 2, we would have ended up with the same interval. So that is our correct answer. Okay, example 4, we already have that one 0 on one side, so now we're going to solve the absolute value that's on the left side by graphing it. So we're going to make a table again. Our vertex is going to be at 2, negative 3. Pick two numbers to the left, negative 1, or not negative 1, 1 and 0, and then two numbers to the right, 3 and 4. And just run those through the function. 0 minus 2 is negative 2. The absolute value of negative 2 is 2, and 2 minus 3 is negative 1. 1 minus 2 is negative 1. The absolute value of negative 1 is 1. 1 minus 3 is negative 2. 3 minus 2 is 1. The absolute value of 1 is 1. And 1 minus 3 is negative 2. And 4 minus 2 is 2. The absolute value of 2 is 2. And 2 minus 3 is negative 1. So we have 0, negative 1, 1, negative 2, 2, negative 3, 3, negative 2, 4, negative 1. Now, you'll see that this would continue like this, and it would also continue up this way, like that. So we would have solutions at those two spots. Now it is greater than, so not greater than or equal to. So those would be like open circles, right? We don't include those, but our solutions would be at negative 1 and at positive 5. So we're looking for greater than, so we're looking for the area above the x-axis. So it's above the x-axis, everything to the left of this side and everything to the right of this one. So from negative infinity to negative 1, and then parentheses, that's our good solutions. And then we have a gap where it goes below the x-axis, and then we pick back up again at 5, but not including 5, all the way towards positive infinity. Alright, and that is how we can graph and solve absolute value inequalities. Alright, I hope that was helpful. Just another tool to put in the tool chest to have at your disposal to help you out. Alright, if you have any questions, let me know. Happy to help. Shoot me an email or a Canvas message.